There we go. So the first thing I want to do in this review today is I had a student yesterday ask me if there was a formula sheet, and it's right here in course information. I don't know if this was shared yesterday, but it's there here under course information. So let's have a look at this formula sheet before we get started. Again, you guys are math 1730, so you're, I guess, pretty familiar with D2L at this point, but basically everything you need would be in content, and then course information, class recordings, and then there's some other stuff below which we're going to look at today. For example, I guess, actually, it's all right here. If you look at the top half of the course, that this is basically what you'll need to look at tonight, say after your exam. I don't expect this to be too challenging of a test because Unit 1 was pretty straightforward. Unit 2 had some tricky, difficult questions at the end, which we're going to look at today. Yeah, so here we go. First things first, let's look at that formula sheet. So I'm going to go into course information. I'll click on formula sheet. And here it is. Now, one disclaimer about the formula sheet. This is the formula sheet you will also get for your final exam, for example. So this formula sheet is for the entire course, which means you're not going to need everything on this. So if you look at the formula sheet, the first page is all about unit conversions. Very important page. You'll need unit conversions for chapters 1 and 2 because even though chapter 2, we didn't really look at unit we didn't, I guess, go over unit conversions in chapter 2, but some of the questions needed these conversions, like changing, for example, like a quart to a gallon, or a pound to an ounce, or a pound to a gram. Some of these you'll need in both chapters. So here on the first page of your formula sheet, I've given you basically everything, including the number line. The line that I said I would give you, hold on here, this line. And you also get a table, 2 tables to help you do your conversions. We use the line mostly in class, but anyways, this will come in handy for all of your unit conversions. There'll be no unit conversions that on your test that you don't need to know, or that's a silly thing to say. What I mean is there'll be nothing on the test that's not on this formula sheet. So milli and micro, we're not going to really deal too much with anything outside of some of the more common units. Like, what I mean is the base unit, milli, micro, maybe centi, because cubic centimeters you might see, kilo for kilograms. These are the common units that most normal humans use. Now, if you go to page 2 and 3, and we'll do some review of this in a few minutes, is the BSA charts, the body surface area, which I imagine I'll do 1 or 2 of these today because most people are going to want to see this. And then on the next page, there's 4 pages are formulas, and you guys won't need any formulas after number 6. All of this other stuff is in unit 3. I don't know if I remember us talking about specific gravity. I wouldn't worry about that one, but it's not circled anyways. So there you go. This is your formula sheet. This will be given to you on everything. tests and final exams, you will be given this. And this would be good for practicing this evening as well. Okay, so what else should you look at? Well, I would go to, well, I mean, you could open up Unit 1 and do any of these worksheets. They all have answers. You could open up Unit 2, do these worksheets, and look at the answers. There's so much practice here you could look at. But if you only had a little bit of time, you might want to look at some reviews for test 1. And more specifically, the sample test would be like the first thing I would probably look at. Again, you can look at as much as you can. For example, if you know in Unit 2 you really struggled with some of those questions like body surface area, maybe you want to look at Unit 2 handout or a Unit 2 sample quiz. Maybe in Unit 1, you really struggled with metric conversions. Well, maybe you could do the metric conversion worksheet. But if you just had one thing to do, I would stick with the sample test here, which I'm going to open up, obviously, in another tab. So this is kind of what I'll go through today. We'll look at some of the questions here. So this is just a sample test. Very much like your test. There'll be 10 multiple choice and a selection of short answer questions, about 10 or 11 of them. Like, it's basically the same test. I'll just have different questions there. But this is it. This is what you're going to kind of need to know for tomorrow. So let's look at a couple of these. And guys, anything that you really need to see, you can mention in the chat. I'm going to go over a couple of questions or a couple of things at the beginning, like just get some unit conversions out of the way. And then, you know, you guys, the solutions are online, but maybe some of you would really want to see a body surface area question. So we could look at some of those before you leave. Okay. Sorry, there's a message in the chat there. Oh, I'm getting lots of private messages. There's no solutions for these. There is solutions for this. So these are the two that I would look at for the solutions. These solutions aren't available. But if you guys do have any questions from those, you can let me know. Oops. Okay. So first thing I need to do is I need to download this because I don't like working in what's it called? D2L. Okay, hold on now. I'll share a new screen here. All right. So, oh, I didn't mean to do this. Okay, just give me 1 second. All right, that's better. Okay, so let's look at some of these questions here. Okay, well, first things first. So a couple things about the test. Please, I had a Math 1700 test yesterday. It was amazing that how many students didn't bring a calculator. Now, we had all the sections together. So there was like 120 students. It's only 15 of you guys, but please bring a calculator tomorrow. You cannot share calculators, especially during COVID. We're not going to be sharing pens and pencils and calculators. You cannot use a mobile phone. And of course, you're not allowed to talk, but you guys know that anyways. But it's really important tomorrow that you bring your own calculator to the exam room because we can't go sharing things. Oh, I'll make a post today too where the exam room is, but I'll get to that later. But your exam is tomorrow. It's not an exam, it's a test. It's tomorrow at 9:30. And I have the classroom booked. I'll let you know where it is after this class. I just have to open up an email. I'll post where it is on D2L, by the way. Okay, question number 1. Which of the following is a metric unit for mass? That's a pretty easy one. Metric, we're using grams. Kilograms would be a version of that, but pounds is the American or imperial unit. Meter is the unit for distance. Liter is the unit for volume. So that one's pretty easy. Gram. I don't know what's going on with my voice today. Now we get into some unit conversions. So question number 2, how many kilograms are in 1,500 milligrams? So just very quickly, I'm going to show you how this works. I'm going from milligrams to kilograms. So what I'm going to do is I'm going to open up my formula sheet. Okay, I'll share my screen in a second. Okay, and I think for something like this, it's pretty easy to use the number line. So I'm trying to go from, sorry, let me, there we go. Milligrams to kilograms. So I'm going from milli to kilo. So basically what I'm doing is I'm going 1, 2, 3, 4, 5, 6 places left. I'm going to move my decimal place 6 places to the left. Okay, that's it. It's a little easier to do it on the number line than it is on the chart. And I'll show you how it works on the chart as well. For example, if we were going from milli to kilo, the difference here in decimal places is 10 to the minus 6. Okay, so we're going again 1, 2, 3, 4, 5, 6. I would use again the number line for most of this. Okay, so back to the sample test. You would just take 1,500 milligrams, move the decimal place back 6 places, and you would get A. I'll just circle them. Now, another one I'll show you, and then, well, I mean, we can look at as many of these as you want, I guess, but I know you guys have an exam today. What about if you're going from, an imperial unit to a metric unit? Something like number 3 is important to know, is also for the BSA calculations. Be careful with feet and inches. What you really want to do is convert that to inches total and then change it to centimeters. So, hold on now, I'm just bringing up the formula sheet for myself as well. So step number 1, what is 5 feet 7 inches in inches total? Because I know that according to my data sheet, this is in my conversion sheet, I know that 1 inch, oops, sorry, my brain, 1 inch is 2.54 centimeters. So first things first, oops, I want to find out how many inches are in 5 feet 7 inches. So first things first, I'm going to convert 5 feet to inches. So 5 times 12 is 60 inches. Then I'm going to add my 7 inches. Oops. This person will be 67 inches tall.
Mr. Can share the screen?
Oh, yeah, sorry. That's awkward because I've been working for a long time. You should have let me know earlier. So sorry, so there's the answer for number 2. I moved the decimal place back 1, 2, 3, 4, 5, 6 places to get this one. For number 3, 1 inch is 2.54 centimeters. So if this person is 5 feet 7 inches tall, they are 67 inches tall. 5 feet is 60 inches. Then we add the 7. So now all I have to do is multiply the 67 inches by my conversion factor, which I'm writing way too big. And you'll get your answer. Okay. So that's it. Sorry, I'm writing a little messy for that one. But my answer, if I did that, would be D. All right. Now, what about this one? I won't do all of these, by the way. Let's just, like these are all unit conversions. So let's look at, I'll just do one more. So how many, let's look at number 6. How many cubic inches are in 6 US gallons? Okay, so you want to go to your formula sheet. Well, and this one's actually pretty easy because right on my formula sheet, it says that 1 gallon US is equal to 231 inches cubed. So I'm going to multiply 6 gallons by 231 over 1. Oops, and that's it. So my answer there would be 1,386B. All right, so you guys can practice those. I highly recommend practicing these, but I'm going to move into some of the short answer questions. Abdullah, you must have been late to class. Formula sheet is given. I mentioned that, and this is the format of your test here. So there's 10 multiple choice, and then there's a selection of short answer questions.
Sir,
Yes?
I have a question.
Yeah.
So, sir, when do we use 10 raised to power minus 6 and when do we use 10 raised to power plus 6?
Never. I wouldn't do that. I would just use my number line. You can use, it's up to you. I don't want to teach anything too crazy new today, but it depends on if you're going left or right. So like if you're going left, you would go minus 6. If you were going right, I would go plus 6. So I guess that answers your question. Yeah, but instead of doing 10 to the minus 6, you can just count the decimal places as well. It's whatever you want to use. But minus 6 would be going to the left. Positive 6 would be going to the right.
Okay, thank you, sir.
No problem. All right, so let's look at some of the constructed response, meaning the short answer question. The constructed response just means short answer. So most of these are pretty, some of these I should say are pretty straightforward. Like number 1, very easy. In a certain compound, for every 8 grams of drug A, there is 12 grams of drug B and 3 grams of 12C. So A is kind of setting you up for this. It says, what is the ratio? Well, the ratio, very easy. We have 8 grams of A, 12 grams of B, and 3 grams of C. That's pretty easy. But B is actually applying that question. So B says, and let me just make sure I'm sharing the correct screen. Okay, good. If the compound has 60 grams of drug B, excuse me, how many grams of drug A would be present? Okay, well, here is where we can set up what's called our equivalent fractions or equivalent ratios. So we're looking at A and B. So typically, drug A would be 8 grams. Drug B would be 12 grams. That's our typical ratio. What we're trying to do now is see how many grams of A we would have if we had 60 grams of B. So that would just mean we would cross multiply, and you would get 8 times 60 over 12 for your answer of 40 grams. 8 times 60 over 12. All right, not too bad there. Sorry about that. Just had to take a drink because my voice. I'm losing my voice. I think I was yelling a lot in the exam yesterday because we were in the auditorium. We had like 120 something students. So, and then I had class all yesterday too. So I haven't stopped talking in like a long time. All right, number 2 is the same as number 1. It's just a ratio question. There is a little bit of extra work at the end here, which I'll show you actually. So, okay, 25 grams of ointment contain 5 grams of calamine. How many grams would be, well, actually, and this is where you got to be careful, how many milligrams would be in 70 grams of ointment? Okay, well, these are ratios. I know that 25 grams of ointment would have 5 grams of calamine. And what I'm trying to do is to figure out how many grams would be in 70 grams. So I'm going to set up my fractions again. It doesn't really matter which you put on the top and which you put on the bottom because we're going to cross multiply. So 25 over 5 equals 70 over x. What that means is x will be 70 times 5 over 25. I'm just cross multiplying and solving this. You guys can, if you have more questions on cross multiplying, you can let me know. But the answer here will be 14 grams. But that's not what the question is asking for. It's asking for milligrams. So how do I change milligrams to grams? I won't keep doing these unit conversion ones, by the way, but I just had that question a minute ago. So I have milligrams, whoops, and I'm trying to get grams. So 1, 2, 3. What you would do, or what you, that's not wrong, but I was going the wrong way. Sorry, I have grams. I have 14 grams, and I'm trying to go to milligrams. So what that means is I'm going to move the decimal place 3 places to the right, or multiply by 10 to the positive 3. 10 times 10 times 10. So because I'm going to the right, I'm going to multiply it by 10 to the power of 3, or you could just move the decimal place 3 places, whatever you're comfortable with. So that would be 14,000 milligrams. All right. Sorry, I'm just going to open up something there. Boop, boop, boop. Hold on, guys. 1 second here. I just got an email. I want to check something out. Okay. So let's keep going. Sorry about that. Okay. So this one says, how many milligrams of liquid medicine would provide a patient with 3 tablespoons twice a day? Okay, so this is a good one. Oh, and we're doing it for 12 days. Okay, couple things to unpack here. We're looking for milliliters of medicine, but the measurement is given as tablespoons. This is a very old kind of measurement, but very common for like a home liquid medicine. So we're trying to figure out how much medicine would we need if they're going to take this dose 2 times a day for 12 days, and every dose that they take is 3 tablespoons. So let's make a little list here. I know that they're going to take 3 tablespoons for every 1 dose. And they're going to take 2 doses for every day. Now, there's one other conversion factor I need, though. It's looking for milliliters. Well, how many milliliters are in a tablespoon? Well, that's in your data book, or I'm sorry, I'm thinking about being a chemistry teacher. Your formula sheet says that 1 tablespoon is 15 milliliters. So using all of this information, we should be able to find our answer. All right, so they are going to take 12 days worth of doses. They are going to take 2 doses per day. Now, think about this step by step. 12 days, 2 doses per day. So that's 24 doses. Like they're going to take the medicine 24 times. You guys know this, I'm sure, but a dose is just like every time you take the medicine. So they're going to take the medicine 24 times. But I can't stop here because, well, how many milliliters are in all of these 24 doses? Well, I do know that each dose, they're going to take 3 tablespoons every time they take a dose. Almost done. The only other thing left is I need to convert this into milliliters. And that's it. You'll get your answer, 1,080 milliliters. So they're going to take about a liter of this medicine. I feel like that's a lot. Like from my experience, this is just I'm killing time or being silly, but when typically for me, when I was a kid and I'd be taking liquid medicine, it'd just be 1 tablespoon. So this person's taking a lot, 1,000 liters over 12 days. Oops. All right, cool. Let me just do something here. All right, let's keep going. Okay, so number 4. If 10 tablets contain 250 milligrams of ibuprofen, how many tablets should contain 1.5 grams of ibuprofen? Now, for anybody kind of waiting for me to get down to I know some of you didn't like the body surface area. We're going to do that in just a minute right after this one. I just figured we might as well do number 4 since we're here. So 10 tablets contain 250 milligrams of ibuprofen. How many tablets will contain 1 gram? Well, we need to think about some things. So first things first, I know my first ratio here is that 10 tablets are equivalent to 2,500 milligrams. The other thing I know is that 1,000 milligrams equals 1 gram. Or 10 to the 3 milligrams is equal to 1 gram. That's just from my data booklet. Or sorry, if you hear me say data booklet, I'm just saying, I mean formula sheet. So we have 1.5 grams of ibuprofen total, and I'm trying to figure out how many tablets would be 1.5 grams. Well, I know, first things first, what I need to do is change this to milligrams. So you could move your decimal place, you could do whatever you need, but first thing is this needs to be in milligrams. Okay, so if you're a decimal place person, you would move it 3 places. So I'm just going to keep with what we call this dimensional analysis. I'm just going to keep this here. But you could just, and you don't have to do this all in one step is what I'm trying to say. You could convert the milligrams to grams like over on the side over here, and then start with this step is, well, I need to convert the tablets into milligram, or well, sorry, from milligrams, I need to convert it into tablets. And we'll get the answer. It's a nice number. It's 6. Now, if you did this on your calculator and I just wanted to mention something about your numbers in this course. When you're dealing with like medicine, the things like doses and tablets, try to round them up to the nearest whole number. So I'm not saying this is the answer, but it's like if this question, if you got like, 5.44 tablets, well, it's really hard to kind of take 0.44 of a tablet. So you could say 5.5 tablets or 6, but just kind of think about medicine when you're rounding. Think about like if you're delivering a dose, the dose should be rounded up to the nearest whole number. So again, like if it said 12.8 doses, a doctor would probably just prescribe you 13. Okay. Anyways, just a suggestion. I'm not going to take off marks for significant figures like I would in chemistry. Okay, number 5. Using a nonogram, find the body surface area for a child that is 2 feet 6 inches and weighs 30 pounds tall. Or weighs 30 pounds tall, is 30 pounds. Okay, so a couple things that are really important here is that this is a child. Adults and children have different body surface area charts or nomograms nomograms, because the surface area difference of a small child and then a fully grown adult. The other thing we need to know is the height and weight of this person. Okay, so child chart, 2 feet 4 inches, 30 pounds. All right, let me go to my chart. So here you can see my screen here. The adult chart is first. The child chart is on page 3. Okay, sorry about that. I just got a question in the chat. It says, if you saw, every year a student asks me this for everything. If I solve the sample, will I be okay? I don't know, because it depends on you. You might need more practice. So I would do as much practice as you can. Try as many worksheets or questions from the book as you can. But I will say, if you could do this test, you would be, I can't say okay, because if you get a 50, you'll be mad at me. So I would study as much as you can, but if you didn't have much time, I would start with the sample test. That's the best answer I can give. Okay, so back to this question. I'm in the child chart, and 2 feet 4 inches. Okay, so 2 feet 4 inches is, sorry, let me get my pen going. So this kid is 2 feet 4 inches. So here's 2 feet. Here's 4 inches. So I'm going to put a dot there. If you don't like using feet and inches, you could convert this to centimeters, up to you. Now, the child weighs 30 pounds. So the pounds are over here. 30 is right here. So now what I do is I draw a line that connects these 2 points. Well, that's not very good. Hold on. Okay. And where they cross the middle line is the answer. And this crosses at about 0.48. Now, the units for surface area are meters cubed, which it does say this on the top of the graph. There is some subjectivity to this answer. So if somebody said, like, again, it depends on how you draw your line. But if it was 0.4, if you said 0.49 or 0.47, that's fine. If you said 0.4 or like 0.52, you would be way off. But as long as you're kind of in this little region here, you're fine. So what I mean by that is, your line should be in this region. It would be very strange to be outside of this region. But anyways, this is 0.48 meters cubed. Okay, now let's apply this to an actual kind of question. Okay, so we'll look at number 6. Okay, so the answer for number 5, 0.48 meters cubed. Again, if you said 47, 49, that's okay. You don't need to bring a ruler to your test tomorrow either. You can use the side of your calculator or something. What I'm saying is I wouldn't go out of my way to buy a ruler for tomorrow. You could easily just use the side of your calculator, or you could almost freehand it, but I probably would use like your student ID would make for a very good ruler for that. I'm not going to be checking your IDs. I don't care. Well, I mean, I do care, but I know who you are. It'll be fine. But you could use your credit card or student ID as well. Like, don't go out of your way looking for a ruler. I would go out of your way to get a calculator. Okay. So the usual adult dose, keyword here, adult, of a certain drug is 250 milligrams. What would be the dose based on body surface area for a person who is 70 inches tall and weighs 80 kilograms? Okay, so there's a little bit of work involved in this. We need to figure out how tall this person is, and you'll see why in a minute. And we know their weight in kilograms. That's okay. And we need to figure out their body surface area first. So first thing I would do for this person is find their body surface area. Now, if you go to the chart here, obviously go to an adult. The chart here does give weight in kilograms. That's good. So the kilograms aren't a problem. However, it gives height in feet or height in centimeters. And there's 2 ways you could do this. You could convert the feet into inches, right? And then, you could convert the 70 inches. This person is 70 inches tall. You could convert the inches into feet, which I remember we had a little bit of trouble with in class. A lot of people had trouble understanding that there's 12 feet in an inch. So like this person, first thing you would do is you would divide 70 by 12. And this person would be 5 feet tall. And then you would subtract that from the inches, or subtract what's left over. So this person would be 5 feet 10 inches tall. That's very complicated, or especially if you never grew up measuring in feet and inches. I always did. So if you got a number like this, it's a lot easier. Instead of worrying about converting it to feet, is to just convert it into centimeters. And I know that in 2.54 centimeters, there is 1 inch. So this person would be 178 centimeters tall. I'm going to round it. My calculator said something a little bigger, but, it said 177.8. So I'm just going to round it. Okay, this is a lot easier because now I can put a dot here at 178, and I can put a dot at 80 kilograms right here. And then I would use, like I said, my student ID or my calculator or something to draw a line here that connects them. And from my body surface area, I get 198 meters squared. Or sorry, 1.98 or 1.95 meters squared, I guess. So this one, I get 1.95, and I said meters squared. I'm thinking it's meters cubed, of course. Okay. Now, again, this is a tough graph to do. So you might say 2 meters squared, depending on your line. You might say 1.93 meters cubed, not squared. I keep saying squared. I'm not going to be taking off marks if you got different numbers. I think in the answer key online, it said 1.98. It really doesn't matter. As long as you're around 1.9 to 2 meters cubed, that's good. Okay, so now I go back to my question. Okay, sorry, I just had to comment on something. Back to my question. I'm going to clear my drawing, guys. And I'm just going to make the note that I figured out that the body surface area of this person was 1.98 meters cubed, or not 9.5. Okay, next step. The usual adult dose for a person is 250 milligrams. So we need to find the body or the dose for someone who's a different weight than the typical adult. So here then you could go to your formula sheet. Okay, and on your formula sheet it says that, oh, it is meters squared. That's no wonder I was saying meters squared. It is. There you go. I think I said up above meters cubed. I'm sorry about that. Surface area is squared. Volume is cubed. Sorry about that. That's just, I'm trying to like write and talk at the same time. So in your, or on your formula sheet, it says that the normal adult dose for a person is the body surface area of that person divided by 1.73 meters squared times the usual adult dose. Okay, so my answer to this is going to be my body surface area, 1.95 meters squared over 1.73 meters squared times the usual adult dose, 250 milligrams. And that's it. This formula is on your formula sheet. So I'm going to multiply this together. Okay, and I'm going to get the answer of 281.7 milligrams. So I'm just going to say 282 milligrams. Keep it simple. You know, don't need perfect decimal places. Now, guys, just a little reminder. On the answer key, I think it says 286, but that's because my BSA was a little bit off. It really doesn't, like, I'm not looking for specifics here. As long as your answer is around 280, I'm happy. Anytime you use a nomogram, you're going to see some error involved. All right, cool. Let's keep going. I know some of you guys got an exam, so oops. Let's keep going. There's only, I think, 4 questions left. So this one's a big one. This is probably the one what we did in class where it was like the most challenging. So this one you will definitely, I mean, you're going to see all of these. in some way, shape, or form. You know, the units might change, you know, some things might change. Oops. Oh no, nobody said anything, but I don't know if I was sharing my screen here for this. So if I, well, I don't know if I was sharing my screen. So I'll just show you what I did here. I use my data sheet or my formula sheet. Okay. I use my formula sheet to do this. So 1.95 over 1.73 times 250 milligrams. And I think I got 282. Okay, sorry about that. I don't know if I was sharing my screen just then. Okay, so number 7. A prescription calls for 2 tablets every 12 hours for 2 weeks. Okay, a lot of information happening here. If each tablet contains 200 milligrams of C-chlor, how many grams of C-chlor will be taken over the 2 weeks? Okay, so we are looking for a lot of information, or there is a lot of information here. And what we're looking for is how many grams will be taken over 2 weeks. So our goal is to somehow convert 2 weeks to grams. How many grams will we need in 2 weeks? Okay, so a prescription calls for 2 tablets every 12 hours. So 2 tablets is 1 dose. Okay, what else do we know? We know that they're going to take they're going to take the dose every 12 hours. So this is a little confusing way of saying this, but they're going to take 2 doses per 1 day or every day. And they're going to do that for 2 weeks. Now, every tablet has 200 milligrams. So I'm going to kind of leave it there for a second. I'll worry about the grams after. Let's do this conversion. Okay, so step number 1, we're working with 2 weeks. Well, I know that they're taking 2 doses per day, but I need to know first, how many days are in a week? Well, that's easy. Classic conversion. There are 7 days in 1 week. Okay, so if they're taking 2 doses per day, I now converted week to doses. So 2 weeks times 7 days, that's 14 days. They're taking 2 doses a day. That's 28 doses. And every time that they take a dose, they're taking 2 tablets. Oh, I'm sorry, I'm just trying to think if I should do it all in one step or kind of just stop here. Well, let's go one more. So I've converted 2 weeks to tablets. So again, 2 weeks is 14 days. 14 days, 2 doses a day. So that's going to be 28. Now, every dose is 2 tablets. So they're taking 56 tablets. But I can do one more thing here. I know that every tablet is 200 milligrams. And let's stop here. I don't mean stop the question, but let's get the answer here before I do the next part. So 2 times 7 times 2 times 2 times 200. And they're going to be taking 11 1,200 milligrams. Now, the answer, I need to change that to grams. So I move the decimal place 1, 2, 3 places back, and I get my answer as 11.2 grams. All right, cool. This one hard. It's probably one of the. It's not that it's hard. It's just a lot of things happening in this. This would be number 7, literally as hard as these conversions get. Okay. The daily dose of a drug is 0.0015 milligrams per kilogram of body weight. Okay, so I know that the daily dose of a drug is 0.0015 milligrams per 1 kilogram of the person's body weight. How many milligrams should be administered to someone who weighs 55? This one's super easy. How much should we give to someone who weighs 55 kilograms? Easy ratio type question. For every 1 kilogram of body weight, you have 0.015 milligrams. So if the person weighed 55, then we would just take this number. Sorry, I don't want to leave out a 0 there. And we would get our answer, 0.825 milligrams. Okay, we're almost done. I think there's there's 3 questions left. A patient receives 35 drops per minute. These were also pretty challenging when we did these in class. So a patient receives 35 drops per minute of an IV solution. The solution itself would contain 1 gram of the drug per liter, and it drops 18 drops per milliliter. Okay, so the question is, how many milligrams of the drug will the patient receive per hour? Okay, let's again think of what we know. We know that there's 35 drops per 1 minute. We also know that the solution itself contains 1 gram of drug per 1 liter. So we know that much. We also know that this thing will drop 18 drops for every 1 milliliter it delivers. And our goal is to figure out how many milligrams of the drug will the patient receive per hour. Okay, so 1 hour. Well, the first thing we need to do, because we're dealing with minutes, is to change our time to minutes. Why? Because of this number here. We know that there's 35 drops per minute. Well, how many minutes are in an hour? That's 60. So I multiply this by 35 drops per 1 minute. Okay, so now I know how many drops are delivered. What do I need to do next? Well, I also know that in every 18 drops, we're delivering 1 milliliter. Okay, and actually, I'm going to stop it there for a second. Let's just solve this and take a minute to think about this. So, okay, 1 hour times 60 minutes. So we have 60 minutes. There's 35 drops in a minute, and there's 1 milliliter in 18 drops. So I'm going to get here 117 milliliters. Now we're not done. There's 117 milliliters, but the question is asking for milligrams. Okay, so I know that we have 117 milliliters. We know that in 1 liter, I'm just going to write this down, but I will erase it. We know that in 1 liter, there's 1 gram of the drug. The problem is we don't have liters yet. So I'm going to convert this into liters. So I'm going to times this by 1 liter over 1,000 milliliters. Then I can convert this to grams. Oh, and we also need to convert this into milligrams. Sorry, the question's asking for milligrams. So this is actually kind of a funny one because all of this cancels out to just be one. So the answer is also 117 milligrams. So again, what I did was I converted it to liters. I converted the liters to grams, and then I converted the grams to milligrams. But actually, when you do all of that, it just equals one. It all cancels itself out, but that's okay. It's good to show our workings. All right, two more. Any questions before I do the last two? There's only a few of you left. I know you guys, some of you might have an exam in 25 minutes. Any questions before I do the last two? Okay. One thing I'll mention, guys, if there's any questions you think of later today, send me an email. I should be able to get back to you. All right, number 10. This one's a little bit more straightforward. A patient is to receive 1.5 liters of solution by intravenous infusion over a period of 24 hours. Okay, so 1.5 liters over a day. Sorry. All right. 1.5 liters over 24 hours. It says, what is the rate of infusion in drops per minute should be used if the infusion set delivers 15 drops? Oh, I like these ones per 1 milliliter. Now, think about what we're trying to do. We're trying to go from liters per hour into drops per minute. This is our goal. Okay, so I need to go from liters per hour into drops per minute. So I'm going to take 1.5 liters over 24 hours, and I'm going to start doing my conversions. Now, first, let's change the hours to minutes, right? I don't want hours, I want minutes. So I'm going to multiply this by 1 hour is 60 minutes. Oops. So my hours cancel. I'm also trying to get drops per minute, but I can't figure out drops per minute until I know milliliters. So I am also going to multiply this by 1,000 milliliters over 1 liter. Now, the reason I do that is because I need to know milliliters to figure out drops. And I'm done. So this would be 16 drops per minute. Well, actually, it's 15.6 drops per minute. And, you know, depending on the medication, you might not be able to calibrate it to that. So 16 drops a minute. It might be a bit too much, but, you know, you let you guys and the doctors and nurses and stuff worry about that. But mathematically, it's 15.65 drops per minute. Okay, bye guys. I'm just doing the last question, so I don't know if you're still here, Reem, but goodbye. I'll upload this to YouTube. Don't worry. Okay, last question. Use the formula below to calculate the amount of each ingredient that would be needed to produce 1.5 gallons of sodium phosphate solution. Okay. This one's actually got a little bit more work than what we did in the class. Well, no, sorry, a little bit more work than like the classic recipe ones that we did. So what I need to do is I need to figure out a conversion factor to multiply all of these by. Right? I'm converting the recipe. Now, one thing though, well, I guess I didn't need to erase that, but one thing we need to keep in mind is how do we calculate our conversion factor? So first thing I'm going to do is I'm going to convert my gallons into milliliters. Now, why am I doing that? Well, the solution total volume is 1,250 milliliters. What that means is when it says purified water, QSAD, that's that Latin kind of, it's not an acronym really, but it means add to the specific volume, the quantity volume. So my total volume here is 1250 milliliters. So what you would do is you would take sodium phosphate, citric acid, and glycerin and mix them together in this amount. Then you would add water until you got this total volume. So the problem is, what is 1.5 gallons in liters? Or even, I guess I should say milliliters, shouldn't I? Okay, so let's do that. 1.5 gallons. If it doesn't specify, I think I will specify it tomorrow. Let me just see something here. This test didn't say, so yeah, we're always going to be using US gallons, and that's like the only one on your formula sheet. So this is a US gallon. 1 US gallon is equal to 3.785 liters. That is for anybody, I know there's not many people left, but that is from my formula sheet. Now, I also need to know how many milliliters I get, which is a classic conversion we've been doing for a long time. So I would get my answer as 5,678 milliliters. Now, I need to figure out then what is my conversion factor, meaning how much am I going to change this recipe by? So my conversion factor is the number I'm looking for. So, you know, kind of like the number in your recipe over the original amount in your recipe. I don't know if that's on your formula sheet. Let me just see. Yeah, this is on your formula sheet. Let me just scroll up for a second. The formula on your formula sheet says the conversion factor is the quantity desired over the quantity of the formula. Okay, so it's the number that you're looking for in the recipe divided by what the recipe says. And when we do this calculation, we end up getting 4.54. Oops. Two, I guess. Actually, let me just double check that on my calculator, guys. 1 second. 4.5424. Okay, 4.54 is enough. So now what I do, so this, what I'm looking for is 5,678. This is what I'm looking for. So I'm going to multiply each of these by my conversion factor. So I'm going to multiply everything here by 4.54. Okay, and that's it. So I'll end up getting 3,430 grams, 590 grams, and 681 grams, or milliliters for this case. All right, guys, that's it. That would be the end, the last question in Unit 2. So guys, that's it for me. There's a few people left here. There's about half of you left. If does anybody have any questions? Okay, excellent. No questions. That's awesome. So for the people who are still here, if you are studying tonight and you do have questions, send me an email. Thanks, everybody. Goodbye. Have a great day. Good luck if you have an exam. Thank you so much. Have a good day, everybody. And I am going to put this on YouTube now, so you can look for that soon. Okay, goodbye, everybody.